So 1.7 fractions and rational expressions. So we go back to fractions, but now we are adding factoring in, okay? So we were already doing fractions with factoring, but not factoring polynomials. When we have a fraction, like 45 over 27, and we want to reduce that, we actually factor the numbers. We find the factors to see what cancels out. So this is 9 times 5 over 9 times 3, and those numbers are now said to be factored. So factored is anything that are multiplied together to get you your bigger number in this case, or your quadratic expression. The 9's cancel. So we've been doing that all along. We did see things maybe of this sort, or you would be expected to know this already, a common factor. We did do common factors when we did the fractions earlier. So you can factor out a 2 on top, and a 3 on the bottom. Oh, interesting. So instead of, I was thinking the number was going to cancel, which of course it doesn't. So what cancels here? So these are factored. We've got two factors on top, a 2 and an x plus 1 is the other factor. So the x plus 1 are the same on top and bottom, so they cancel. And we have 2 over 3. Now it's sometimes going to be important to look at, especially in calculus, what numbers didn't work in the original expression, because although this first expression is equal to 2/3, the domain or the x values that work are different now than from the start and the finish. So we did change it by canceling something with an x out. Why am I saying x can't be negative 1? Where did that come from? Right. Any fraction, a fraction can't have a 0 on the bottom. Can it have a 0 on top? Or can't have 0, yeah. It can have a 0 on top, yes. Can't have 0 on the bottom because we can't divide by 0. So here we had 3x plus 3 is the denominator at the bottom. And it can't be equal to 0. And to solve something that we put like cannot equal, it's just the same as solving it with an equal sign and then crossing the equal sign out. So 3x is equal to minus 3, x is minus 3 over 3, which is negative 1. So we say x cannot be negative 1. If you plug negative 1 into the bottom, you get negative 3 plus 3, which is 0. That won't work. What do you get on top if we plug that in? Just also 0. But that doesn't matter. It's okay. Right? It just happens at the same number. So x can't be 0. So we usually put that. That's called a restriction. Sometimes the restriction matters, so it's good to sort of remember about that when you see a fraction. Okay, so now instead of linear, which the last example was linear, the highest power is just x to the 1. We have quadratics that we could have. And to factor these, we use our factoring techniques that you've all mastered. So, how do we factor the first one? So, the way I factor without writing the multiply and add off to the side is like this. I say I can probably factor both of these. Two numbers that multiplied give negative 2. 2 and 1. And I need those two numbers to add to give a negative 1. So which way would the signs go? The 2 has to be negative because the answer is negative, more negative than positive. And there it is. So you could do those numbers off to the side and then write them in if you wanted to. Negative 8. Two numbers that multiply to give negative 8. 2 and 4. or 4 and 2. We want them to add to give a positive 2. So positive 4 minus 2. Okay, so once you have it factored, we say, do they have a common factor that you could cancel? Yes, the negative 2. And so our answer here is x plus 1 over x plus 4. What would the restriction be? The restriction that you canceled out. What makes the bottom of this 0? Or what makes x minus 2 0? Plugging in what number? A 2. 2 minus 2 is 0. So x cannot equal 2. Could we put the other number that makes the bottom 0 is the negative 4? Do you agree with that? Yeah. Could we put that as a restriction? Yeah. But it's not needed. Why not? So we could also say that x is not negative 4, but that one's not needed because it still can't be negative 4 here. We didn't cross that part out. It's not missing. Right? So this is saying, like, normally you would just care about the ones you canceled out. But the domain is still the same, that we can't plug in to, so the domain here, we would say that x cannot equal 2 or negative 4, semicolon, x is an element of real numbers. So the original question has, and how do we figure that out? If you take the bottom and factor it, it will give you the factors and you can look at them. You say, what do I plug in here to get a 0? Negative 4. And what do I plug in here to get a 0? 2. So I can't have a negative 4 or 2 plugged in, or else we'll get a 0 on the bottom. So we can plug in any other number, because we can have a 0 on top, we can have a negative number on top, a positive number, a fraction, a decimal, it doesn't matter. We can plug in anything else at all, just not these two numbers, because they make a 0 on the bottom. Okay, so that's what we would say the domain. And if you were reading this, this is set brackets. So this is saying the set of all x. That line is read as such that. Then here's our condition. X is not 2 or 4. And, but, or, and, x is an element of real numbers. So it just means x can be anything else other than the condition. Okay, so you'll see that in calculus. They'll actually do domain as a topic in calculus, but if we introduce it now, when you get to that, it'll be easier. So we can have a question that's sort of mixed. We've got a quadratic on top and a linear on the bottom. You can maybe factor one or both, because you can factor linear equations if they have a common factor. So does the top have a common factor, first of all? Yeah, it does, a 3. And you just always check for that. When do you know to do that? When every single question you check for that. These ones I didn't mention it because I see that there's none. But if there had been a common factor here, I would have factored that out first. So 3, we are left with x squared minus 4. On the bottom, is there a common factor? 2. X plus 4. Can we factor further? Yeah. The top is the difference of squares. X plus 2x minus 2. All right. Now, does anything cancel?
Can you factor the bottom first?
No. No, because it doesn't have an x squared. So nothing factors. So this original equation was already simplified as far as it can. Just like a normal fraction with numbers, we can't always simplify them, even though you could factor them. If we had, say, example 45 over 22, does that reduce? it doesn't. This is 9 times 5, and this is 11 times 2. We can factor them, but they don't always reduce. Right? So the same thing with a polynomial. You can factor it, but you just say, okay, that doesn't reduce any further. Now, there is still a benefit to doing that, because in calculus you're going to set this equal to a number, and then you have to solve. And to solve, you would need to factor it. So it's still a benefit to do that, but this, nothing cancels. Does that mean no solution? No, because we're just simplifying. Here, nothing cancels, so that would be as small as it gets, right? That would be your answer. You don't simplify it any further. Yep.
On a test, would you prefer to see 45 over 22 or 9 times 5 over 11?
45 over 22, yeah, for numbers. These, we usually leave them in the factored form, but it doesn't matter again. Yeah, unless I said one way or the other, right? Nothing cancels, so it doesn't simplify. Okay, it doesn't mean no solution, it just means we couldn't simplify that one. Now, this was a really good question for sort of trickiness. Does anyone think they would have got that wrong and done something to make sure something canceled? One thing that people do sometimes is the difference of squares. They forget to take the square root of the 4, and they put a 4 and a 4. Sometimes you would just go right to here and not factor that and cancel out the 4. Can anyone see themselves doing that? People do that a lot, but why doesn't the 4 cancel here? The 4 is not multiplied by something on top, right? It has to be a factor, which means multiplied. So this isn't 4 times x squared, it's x squared minus 4, it's subtracted, right? So they can't cancel. So what if we had had this question? Factor 3 out of the top. Factor 2 out of the bottom. And you see it's going to cancel this time? So what cancels? X plus 2. Now I canceled out something with an x in it, so I need to put my restriction. What can x not be? Negative 2. Right? Negative 2 plus 2 is 0. And you can always do that by just setting that equal to 0 and solving for x. And so our answer will be 3 onto x minus 2 over 2. If it says to write the restriction, you have to, but if it doesn't, it's not really part of it. But when you go on and do something else, it's good to have the restriction in your mind that you canceled that out. So it did change the question. They're equal only if you don't plug in negative 2, basically. Okay, so here we've got a 2 in front of the x squared. Can it factor out? Are these numbers all even? No. What about on the bottom? The 2 does factor, x minus 3. Okay, so we need to check whether the top factors are enough to see if that x minus 3 will cancel. That's really our only option. So we need to factor 2x squared minus 5x minus 3. So we need two numbers to multiply to give, remember if there's a 2 or a number in front, 2 times minus 3, which is negative 6, and we want them to add or subtract to give negative 5. So 6. Will 2 and 3 work? 2 times 3. How can we put the signs to make those equal negative 5? Both negative would give negative 5. But if we have both negative, does that multiplies to positive 6, not negative 6? Right, so that doesn't work. Remember, they have to subtract. If that sign is a negative, they have to subtract to give 5. So 3 and 2 subtract to give 1, not 5. They don't work. What's another option? 6 and 1. So 6 and 1, they do subtract to give negative 5, negative 6 plus 1, and they multiply to give negative 6. So remember with these ones, you break up the minus 5x using this, so minus 6x plus 1x. This is the middle part. Then what do we do? Factor it in parts. So 2x, x minus 3, and 1. And if nothing comes out, factor it a 1. Sometimes a negative 1, I think on your homework was a negative 1 for the last section. And what are our factors? 2x plus 1 and x minus 3. Now I've got a whole bunch of stuff in the middle, so I'm actually going to rewrite the question. So the top factors as 2x plus 1 times x minus 3, and the bottom was 2 times x minus 3. So we factored the top, and I did it sort of off to the side, and then put it back in. Just make sure you rewrite the question. You're sort of starting over again. Okay, so you don't want just this mess to equal that. You need to start the question over because we did just the top off to the side. Now the x minus 3 cancels. What would the condition be? Right, it can't be 3 because we don't want x. We're going to cancel that out, and it's going to be gone, so we can't see it. So 2x plus 1 over 2, and x cannot equal 3. What about canceling those 2's? That 2's multiplied on top, isn't it? It's times x. It's not times the whole top. It has to be multiplied by everything. So no, you can't cancel that. Be careful. This is not 2 times x plus 1. It would have to be like that for it to cancel, not just 2x. Because what are we doing is adding the 1 to it. There is not, in fact, that would be an odd number no matter what you plugged in. It is not, doesn't have a factor of 2 in it. If we put a 3 in there, what do we get? 2 times 3 is 5, or 6, plus 1, 7. Does 7 cancel with the 2? No. No matter what number I put in here, 2x plus 1, 2x makes it even. Adding 1 more makes it odd. That top is an odd number. It cannot cancel with 2 no matter what you do. Okay, so that would be your answer. Okay, so write this question down. We've already factored the bottom. We just did it in the last question. The denominator of this is the same polynomial as was on the top of the last question. So you do this one. Write it out and figure out what the restriction is that you canceled out. is the top factor? No. And the bottom was what? 2x plus 1 times x minus 3. What cancels? The 2x plus 1, so we need the restriction for that. 2x plus 1 equals 0. Negative 1/2. So x can't be negative 1/2. Once we cancel that. Now, what do we write this as? 1 over. Be really careful of that. If the whole top cancels, we're left with a 1. Okay, so sometimes you don't have to factor both one factors and not the other. For example, if we had 9 over 45, the 9's cancel. This is not equal to 5, it's equal to 1 over 5. Right? And what if it were the other way around, 45 over 9? It is just 5. Right? 9 goes into 45 5 times. Right? So you can have the whole numerator or whole denominator, the whole top or bottom cancel, but you have to remember to put a 1. Do we need a 1 here? No, you could. It's not wrong, but that anything divided by 1 is just itself. So what do we do first? Common factor. On the bottom. Now what? The 3 and the 2 can simplify, or you can factor the 3 if you wanted to. Or the 6, sorry. There's 3 times 2. What about the x plus 1? Does that factor? No. It's a sum of squares. When there's a plus in between, it does not factor. So that cannot be reduced further. What about the bottom? That's a difference of squares. It does factor. X plus 1, x minus 1. Now what cancels here? The 3. How many factors are on top? 2 factors? And on the bottom, 1, 2, 3, 4 factors. There's 4 things that multiply. The 3 is the only thing that cancels. We don't need a condition because we didn't cross off anything with an x in it. We can leave this all factored if we wanted to, or we could multiply out the bottom again. But we want to leave them as factored for later. Okay, so that would be all you can do, just the 3. So don't get looking at the first one and thinking, like getting excited, oh, there's an x squared and an x squared, cross those off. People do that a lot. You get lots of weird answers, actually. All right, so what we're going to do now is fractions that aren't just one fraction yet. It's 2 fractions. You have to find the common denominator first, put them together, and then factor the top and bottom. Okay, so that's the next part of this.